Kenzie? Okay. So this wouldn't be something that would appear on the homework quiz, just FYI for everybody following along. But 15 to 16 is going to be something we'll do entirely on the calculator. So it asks us to solve for tangent on that interval. So I'm going to just do this graphically. So I'm going to think about, this is basically saying like theta equals tan inverse of 1.3. Now, I know that tan inverse is never going to give me an answer in that range. So if I'm going to use my calculator to do this, I have to take and like convert it back into tangent rather than tan inverse. Is that okay, Mackenzie? Okay. So in my calculator, I'm going to do tan x is y1 and the 1.3 is y2. So basically each side of the equation is one line in my grapher. And then I'm going to go to my window, and I'm going to set my window, the x range, to go from pi to 3 pi over 2. And then I'm going to just hit graph and look for the intersection of these two lines. So here's the 1.3. Oh, I'm in the wrong mode. I need to be in radian mode. So there's my graph of tangent. There's my graph of 1.3. So my solution is right here, this intersection. So I do second, trace, intersect, enter, 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 and my answer should be like 4.06. Is that okay? So I just did one side and then the other side. Yep. But it's all in my calculator. I didn't really write anything down for that. Grace. Which worksheet? 2, number 5, you say? Okay. You're a little muffled, so I want to make sure. I surely picked both of those. And you said 5? Okay. All right, so we'll start by drawing ourselves a picture. So 11 pi to 12 pi is like a whole lot of stuff. I'm going to just really only write down the stuff I need to so that it doesn't get so like overwhelming. But I notice theta is positive, so I know I'm going to be going counterclockwise around. So I'm 0, half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11, 11.5, 12. So we're looking at quadrants 3 and 4. Consulting all silly turtles crawl. I know cosine is positive in quadrant 4. So there's my fella there. Let's see, I'm going to go around a whole boatload of times here, huh? 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, and then to my answer. So there's my theta. Yikes. So far, so good. My alpha always formed the acute angle by the x-axis and the terminal side of theta. Since the last axis that I cross when I draw theta is vertical, I know I'm going to be subtracting alpha. And because the x-axis that makes up my alpha is 12 pi, that's what I'm going to be subtracting my alpha from. And alpha is going to be just the cosine inverse, absolute value, 0.19, which again, you don't really need the absolute value there because it was positive already. So again, I already changed to radian mode, so I've already taken care of that. So I just type her into my old calculator, and 36.32 should be my answer. Is that okay, Grace? Sure. Max.
If you, for the same thing to that one, could you just subtract 11 pi from the beginning and then add it back later?
You can't subtract 11 pi because it's not coterminal. It's not like a coterminal quantity. You have to subtract even amounts of pi.
Okay, 10 pi.
So you do like 10 pi,
Okay.
and then add them back at the end. But you couldn't do 11. Is that okay there? Okay. Joe.
Could you do number 5 on worksheet 1?
Yeah. Is there a follow up on this one? There are a lot of hands still up before I move on to a different question. It's on there. Yeah. What's up, Mackenzie? Right. If theta is negative, correct. And I need the unit circle for this, so I'm going to just drop it in here also, so I don't have to go hunting for it later. And Joe, you said 5?
Yeah.
Okay. I'm going to start by drawing a picture for my range. Again, I noticed that theta is positive because it has to be between positive pi and positive 2 pi. So I'm going to be going around counterclockwise. So 0, half, pi, that's my start, 3 pi over 2, and then ending at 2 pi. So we're talking about these quadrants 3 and 4. Using all silly turtles crawl, I notice that tangent is negative in quadrant 4. So there's my theta. So now I'm going to go to the unit circle and try to find the place where tangent is equal to negative square root 3 in the 4th quadrant. To do that, I remember that tangent is y over x. So I'm going to look for the place where the y coordinate has a root 3 in it, and the x coordinate has a 1 in it, inside of quadrant 4. I don't care about the negatives because I've already figured out the quadrant. That'll take care of the negatives for me. So going over to here, I'm looking for the place where the y coordinate has a root 3 in it, and the x coordinate has a 1 in it. So that should be 5 pi over 3. And that's my answer. Paul?
Aren't you saw this about the circle too?
I mean, that's the directions ask you to use the unit circle.
Okay.
So, yes, you could do it the same way we did on worksheet 2, but the directions ask you to use the unit circle. So,
And if you were numbers or anything like that, would it be like 2 pi minus alpha?
Yeah.
Okay.
Grace? Sure. So again, we'll draw our picture. So 0, 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4. So we're looking at quadrants 3 and 4. Again, I just drew the parts that I needed, right? Consulting all silly turtles crawl. I can see that theta should be in quadrant 3 because tangent is positive. So I draw my theta here. So I know that tangent is y over x. So initially I might think, okay, let's go look for a place where the y coordinate is √3 and the x coordinate is +3. There's no regular 3's on the unit circle anywhere on any of the coordinates, so that can't possibly be what I'm looking for. So what I'm going to do is I'm just going to reduce this. I know that regular 3 is the same thing as √3 times √3. So that can just reduce down to 1 over √3. So what I'm going to look for is a place where the y coordinate is has a 1 in it and the x coordinate has a √3 in it. Inside of quadrant 3, again, I don't care about negative signs on any of this because we've already figured out the quadrant. So if I go and do that, I'm looking at this spot here. So 7 pi over 6. So far, so good. Okay. But 7 pi over 6 is not our answer. Notice that when we drew our picture, we went around more than once. So since we went around one full time before we went to the terminal side, I know I should be adding 2 pi to this. Is that okay? And when I make a common denominator and do all that jazz, I end up with 19 pi over 6. Yeah, so each time I go around the unit circle, I'm adding 2 pi. Or subtracting if I'm going the opposite way.
Oh, I see. I just had a So could you do number 10 real quick?
Yep.
Oh, I got that.
Still the same problem.
Yes.
So 0 pi over 2 pi. So we're looking at quadrants 1 or 2. Doing all silly turtles crawl. I know that wherever tangent is positive, cotangent also is positive because they're reciprocals. So if a reciprocal is positive, its reciprocal is positive. Yeah, so we're in quadrant 1. So there's my theta. So I know that cotangent is x over y. So I'm just going to look for the place in quadrant 1 where the x has a √3 and the y has a 1. So if I go back to my unit circle, I would say pi over 6. And I'm done.
Okay. So 5 or 6. If it went over a full time again, then it would be like 13 pi over 6.
Yeah.
Okay. So you're just adding
2 pi.
2. And then if it went the other way, then subtract.
Yeah. You guys ready-ish?
Yeah.
More ready than when we walked in? Or at least the same amount of ready? Hopefully not less ready. Yeah.
Can you do one more example?
Sure.
Can you look for one that has like negative or like so like number 10 on worksheet 2 maybe? Yeah, probably.
Worksheet 2 has number 8.
This one?
Yeah.
Okay. So thetas are negative, so that means that we're going clockwise instead of counterclockwise. So 0, negative a half, negative 1, negative 1.5, negative 2, negative 2.5, negative 3, negative 3.5. So we're looking at quadrants 2 and 3. Doing all silly turtles crawl, I can see that sine is negative in quadrant 3. So again, we're going clockwise when we draw this. So there's my theta. So since theta is negative, and the last axis we passed was vertical, we're going to be adding alpha. And what are we adding alpha to? The end of the x-axis that makes up alpha. And then alpha is just going to be sine inverse absolute value negative 0.44.
So
Yes.
when you're going the other way for the negative, is it the opposite? So like verticals now positive and horizontals now negative, passive?
Correct.
Okay.
So 890, negative 897.
Okay. I don't know what's going on with my calculator, but it's not seems to be doing right.
Are you in the correct mode?
I think so.
Did you press the mode button and confirm that you're in radian mode? Press the mode button. I don't know. This is your calculator.
So numbers.
No.
So when it's negative,
No clue.
Should I Google it real quick? The mode button, is that what I'm looking for?
Yeah.
Do you have an extra calculator? Mine just died.
Every time it's like right here. Every time the last thing you cross is one, that's positive.
Yes.
Like, we went around the full time, right?
That's good. So why wouldn't you be adding like that?
Because I used it, I already accounted for it here. When you're pulling things from the unit circle, you can't account for going around more than once because the unit circle is only giving you things between 0 and 2 pi. On this problem, I can account for going around more than one time by just labeling my axes.
Oh, yeah.